Hi, my name is Belinda and I'm a cancer researcher at the University of Western Australia in the School of Biomedical Sciences.
I work as a part of a team of researchers and clinicians who share a common goal of finding new ways to improve the diagnosis, management and outcome for patients with a type of blood cancer called Myeloproliferative Neoplasms. We're delighted to have received a seeding grant from the Ruby Red Foundation for our study. This support allowed us to perform research to address one of our key aims.
The bone marrow is where blood is made. There are some patients who unfortunately suffer from a myeloproliferative neoplasm. These are groups of bone marrow cancers where the bone marrow makes too much blood. But quite extraordinarily, around 20% of patients will progress to a phase when the bone marrow fails to make blood at all. This is when the bone marrow has become scarred or fibrotic. Once the bone marrow has become scarred like this, it's really too late for curative therapies. What we are trying to do is to develop a blood test that will predict which patients are likely to progress to this end stage bone marrow scarring process. If we can do that, then there are opportunities for patients to have new therapies and prevent them from progressing to scarring of the bone marrow failure, and all the terrible complications that patients will suffer from before they die of this unfortunate outcome. This could be life-changing for those patients.
In our project, we're assessing a special cell in the blood called platelets to see whether it carries any signatures that can be used as indicators of progression. Our study is open for recruitment at multiple hospitals in Perth, and we collect a sample of blood from patients who enroll in the study. From the blood, we isolate the cells of interest, the platelets, and analyze its genetic content using the latest molecular sequencing technology called next-generation sequencing. This allows us to read the entire genetic message in platelets and identify which messages change with disease progression. We can then look for these specific changes in other patients and assess whether they are useful as markers for predicting or early identification of disease progression.
Using our approach, we have developed a panel of markers or a signature which is able to identify disease progression in a small group of patients with high accuracy. This is highly promising and we're now working to refine the signature for clinical application. Going forwards, we need to be able to assess our blood-based signature in a larger group of patients and validate it and show clinical utility. This will require additional funding as well as the continued support of patients, patient support networks such as Ruby Red Foundation and haematologists. Your help will be crucial to help us take this important and exciting discovery from the bench to the clinic. Thank you.